Good morning everyone. My name is Magar MH, Assistant Professor from GMD Arts, BW Commerce and Science College, Sinnar, Nashik. Today I have teach about hydrogen group from MSc first year, course number CHI 130, part 2nd, lecture 4. The point is hydrides. What is meant by hydrides? The hydrogen combines with number of other elements including metal and non-metal to form the compound called as hydride. Okay. All main groups elements except noble gases and probably indium and thallium form hydrides. We know that main group elements means boron to helium. Okay, these are the main group elements. All lanthanides and actinides also form hydrides. The transition metals such as scandium, ytterbium, lanthanum, actinium, technetium, chromium, hafnium, to lower extent vanadium, Nb means nobium, next tantalum, chromium, copper, zinc form hydrides. These, these are form the hydrides. In group 6, only chromium form hydrides. That means CHR is hydride. Okay. Molybdenum, tungsten is not a form hydride. The metal of group 7, 8, 9 do not form hydrides. That means magnesium, iron, cobalt family are not the form hydrides. The region in the periodic table from 0, 7, that means 7 to 9 is referred as hydride groups. Based on their physical chemical properties, the hydrides are classified as: first is saline or salt-like or ionic hydrides. Second is molecular or covalent hydrides. Third is interstitial hydride. Okay, these three are classification of hydrides. First is saline hydride or salt-like hydride or ionic hydride. I have discussed one by one. In saline or salt-like hydride, these hydrides are formed by the metal which are more electropositive than hydrogen. Such metals are located left of the periodic table. Left of the periodic table, that means lithium, sodium, potassium. Okay, these elements form a hydride. The example are alkali and alkaline earth metal except Be. Be means beryllium and magnesium are not the form hydrides. These are formed by transfer of electrons from metal to hydrogen and contain hydrogen as H minus ion. Li plus H minus lithium hydride. Ca2 plus 2H, this is the calcium hydride. These hydrides saline or salt-like hydride, are white crystalline solids. They have ionic lattice and behave like a salt. They have high melting point and boiling point. Conduct electricity in two states, H plus and H minus. Okay. The ionic hydrides are prepared by direct combination of metal with hydrogen at high temperature at about 700 degrees Celsius. The ionic hydride are strong reducing agent. Reaction is 2CO means 2 carbon monoxide plus NaH. It gives HCOO Na plus. Next reaction is SiCl4 plus 4 mole of NaH. It gives SiH4 plus 4 NaCl. The ionic hydrides burn in air on heating and converted into dihydrogen which is inflammable. The reaction is, for example, CaH2, it gives Ca plus H2. The ionic hydride are strong base when they dissolve in water. They form hydroxide and evolve hydrogen. The reaction is NaH plus water molecule. That means H2O. It gives NaOH plus H2. The ionic hydride form complex. For example, LiH plus AlH3. It gives Li in bracket AlH4. This is a complex. Ionic hydride form a complex. Okay. LiH is a ionic hydride. They form complex. This LiAlH4 is lithium aluminum hydride. The next is NaH plus BH3. It gives NaBH4. This is also form a complex. Okay. Ionic hydride. Which hydride? NaH is ionic hydride. It gives Na in bracket BH4. This is the sodium borohydride. These complexes are also good reducing agent. The thermal stability in bracket stability to heat of alkali and alkaline earth metal follows the order. Which order? Alkali metal. Firstly, LiH greater than NaH is greater than KH means potassium hydride. It greater than RbH means rubidium hydrogen. Rubidium hydride is greater than cesium hydride. Okay. This is the thermal stability order. Okay. In alkaline metals, in alkali metals, thermal stability is increase or decrease. The thermal stability top to bottom is decreases. In alkaline metals, calcium hydride CaH2 is greater than strontium hydride is greater than barium hydride. Okay. Alkaline metals, in alkaline metals the thermal stability top to bottom is decreases. The chemical reactivity of alkali and alkaline metals. Firstly, alkali metals. LiH less than NaH, NaH is less than KH, KH is less than RbH, is less than CSH. This is the order of chemical reactivity. The chemical reactivity is top to bottom increases. Thermal stability is top to bottom decreases. Okay, in alkali metals. Second, alkaline metals. In alkaline metal, also same. Chemical reactivity increases top to bottom and thermal stability is top to bottom decreases. The ionic hydrides and their compounds are good reducing agents because they evolved hydrogen when heated, therefore ignite very spontaneously. Okay. First, second hydride is metallic interstitial hydride or transition metal hydride. They are three names. First, metallic hydride or second interstitial hydride or transition metal hydride. Okay. In transition metal hydride, the element of group 3, 4, 5, that means B block element and A block element form metallic hydride. In 3, 4, 5, these elements are including scandium to vanadium. In group 6, only chromium form hydride. Other elements are not form a metallic or interstitial transition metal hydride. Okay. So, metal of group 7, 8, 9 do not form hydride. This region in the periodic table form group 7 or 9 is called as hydride gap because 7, 8, 9, 7, 8, 9 group are not a form hydride. So, it's called as hydride gap. The example of hydrides of group 3, 3, 5, 6 are, this is the table, okay, scandium, ytterbium, lanthanum, titanium, zirconium, hafnium are former hydrides. Scandium H2, YH2, YH3, La, H2, La, H3. These are the metallic or transition metal hydrides. These all elements are former hydrides, which scandium, ytterbium, lanthanum. In group 4, titanium, zirconium, hafnium are former hydrides. In group 5, in group 5, vanadium, niobium, titanium are former transition metal hydride. In group 6, only chromium element form a hydride. Other elements are not form a transition metal hydride. In group 7, 8, 9 do not form hydrides. Based on formation of these hydrides, the D-block hydrides are non-stoichiometric compounds. We know that stoichiometric compounds mean cation and anion ratio are equal in crystal lattice. Okay, and non-stoichiometric compounds means cation and anion are not the same or are not equal in crystal lattice. Because hydride formed in D block are interstitial hydrides. That means these hydrides occupy second site or empty space in the crystal lattice of the metal. Due to this stoichiometry, they have various properties. Which property? First, high melting and boiling point. Second property is lower density. Third property is they conduct heat or electricity. Fourth is hydrides of transition metal are powerful reducing agent. Inner transition metal hydrides. Inner transition metal hydrides. The inner transition metals, that means a block element, form hydrides of limiting composition MH2 or MH3. Okay, inner transition metal hydrides. Inner transition metals means a block element are inner transition metals. All these hydrides are non-stoichiometric with variable composition. For example, ytterbium, lanthanum are former inner transition metal hydrides. YbH2, LaH2, LaH3. These are inner transition metal hydrides. A block metal hydrides are formed when they are reacted with hydrogen at above room temperature. The lanthanides like ytterbium, europium use the hydrides of approximately stoichiometry. All of you, okay? The ytterbium atomic number is 70. Ytterbium second, that means oxidation state is second, is 4F14, 5D0, S 2. पाणी मी मला असं कोरड करते. लेक्चरला पण माझा पूर्ण घसा कोरडा पडून जातो 1.25 तास. Ytterbium electronic configuration is 4F14 5D0 6H2. After oxidation state of ytterbium, oxidation state of 2 for ytterbium in s orbital, these two electrons are lost. Then electronic configuration is 4F14 5D0 and 6H0. It is also same in इकडे आणते. मस्त सर्वात शांत बसू. In europium electronic configuration is 4F7 5D0 6S2. The oxidation state of europium is +2. Then electronic configuration is 4F7 5D0 6S0. In s orbital, these two electrons are lost. Okay. Therefore, they are form hydrides. Which hydrides? YbH2 and EuH2. Okay. These two lanthanides do not form hydrides with formula MH3. That means they are not a form MH3 hydrides because after loss of one electron in f orbital in ytterbium, then electronic configuration is 4F13. After loss of electronic configuration, the orbital is unstable. 4F14 is full filled orbital. All of you we know that half filled, zero filled and full filled is a stable configuration. Okay. In europium 4F7, loss of one electron, the 4F6. In f orbital 4F7 is Half-filled. A half-filled is stable configuration. Therefore, they are not formed MH3 hydride. They are only formed MH2 hydride. Interesting hydride of lanthanum is LaH. The lanthanum electronic configuration is Xe4F0 5D16S2. Then lanthanum oxidation is +3. Therefore, electronic configuration is Fe4F0 5D1 and 6S0. This lanthanum is form a MH hydride, that means LaH3 hydride. After loss of in f orbital electron, they are empty orbital. And empty orbital is stable orbital. Okay. So these are form a LaH3 hydride. In lanthanum, oxidation state is +2. The electronic configuration is Fe4F0 5D1 and 6S0. So in LaH is LaH2, the one unpaired electron in d orbital is single occupied. Now when heat is supplied to this hydride, the single electron move in the lattice of lanthanide and conduct the heat or electricity. Which electron is conduct the heat and electricity? 4F d orbital of one electron is conduct the heat and electricity. Okay. This gives rise conductivity up to 10 ohms per centimeter. The next is molecular or covalent hydride. In molecular or covalent hydride, beryllium and magnesium from group hydride which have considerable covalent character in their bond. Okay. Hydrogen form molecule compound with p-block elements. P-block elements boron, gallium, indium, helium are form a covalent or molecular hydride. In next, this is the group 13. Okay. In carbon family is group 14. Okay. In carbon family, carbon, silica, germanium, tin, lead are form a molecular or covalent hydride. In nitrogen family, that means group 15. Nitrogen, phosphorus, arsenic, antimony are form a molecular or covalent hydride. In group 16, that means oxygen family, oxygen, sulfur, okay, oxygen, sulfur, tellurium are form a covalent hydride. In halogens, all elements are form a covalent and molecular hydride. Which group? Group 13. From this, it can be seen that almost all p-block elements are formed the hydride in the form of molecules. Some of these examples of these molecular hydrides are CH4, NH3, H2O, HF, C3. These are the covalent or molecular hydrides. The stability of p-block hydrides decrease down the group. Okay. In alkaline metals, thermal stability top to bottom increase or decreases. The stability of p-block hydride decreases top to bottom. For example, NH3 greater than CH3 is greater than AH3 is greater than SbS3 greater than BiH3. Okay, that means stability decreases due to increasing atomic number. Because of atomic number increases, stability is decreases. Block element. Among the group, stability of hydrides increases with increasing electronegativity because very strong interaction of electronegative atom with hydrogen. For example, CH4 is less than NH3. NH3 is less than water molecule. Water molecule is less than HF. That means chlorine is more electronegative than oxygen. Oxygen is more electronegative than nitrogen, and nitrogen is more electronegative than carbon. Now we can compare some groups from heat of elements on the basis of their boiling point. Okay, see this chart. Hydride, hydride, NH3, CH3, ASH3, HDH3. NH3 boiling point is minus 33. In CH3, boiling point is minus 87.7. ASH3, boiling point is 2.5. In HDH3, minus 17. Okay. In these are the boiling point of these hydrides. See all of these. The hydrogen of boiling point is water. HF boiling point is 19.4. Okay. H2S minus 16. H2SE minus 41.25. H2T boiling point is minus 2.2. HF 19.4. HCl is minus 85. HBr is minus 56. HI is minus 35.33. From the table, we can say that down the group in every case boiling point of covalent hydride except first element nitrogen, oxygen, chlorine of group 13, 15, 17 respectively. Now boiling point of hydride of top elements like NH3, ammonia, water, HF are abnormally high due to the reason of elements in hydrides. They are form a strong hydrogen bonding. Nitrogen, oxygen and fluorine show strong hydrogen bonding. Therefore, molecules have large polymeric structure. Therefore, boiling point also high. Okay. Thank you, everyone.